Hi, my name is Rajendra Tuturi. I'm a data scientist. So far, we discussed on the skills required for a data scientist, and that is, a data scientist should have very good in statistics. He should be very good in proficient in Python technologies, programming languages like SAS or machine learning, etc. And he should be a subject matter expert and should have domain knowledge. Means so those are the skills we require for a data scientist. And then we discussed on the steps involved in machine learning programming, that is from data collection to the data pre-processing and modeling, machine learning modeling. Third is evaluating the model and testing the model, and then finally deploying. So these are the steps in a machine learning model for using a Python program. That's we discussed. Today we are going to discuss on what are the machine learning algorithms, types of machine learning algorithms. Like before that, we are going to discuss the data types of data machine learning will process it. Okay. Now, the types of data we have in statistics is generally in the types of data is numeric or categorical or ordinal. These are the three different types of data. Generally, statistics is, have, and the machine learning model, our models will machine learning will process structured data and unstructured data. So these are the two different types of data a machine learning algorithm can process it. Which is the numeric further the numerical, categorical, and ordinal. These data will be further divided into these two different types, structured and unstructured data. Now, what are the types of machine learning algorithms we have? One is supervised machine learning, second is unsupervised machine learning, third is semi-supervised machine learning, and fourth is reinforced machine learning. There are other types of machine learning algorithms, but we can discuss later. But these four now majorly. The supervised machine learning is further. What is the supervised machine learning? Supervised machine learning is it processes labeled data. That is, the labeled data in the sense the data, for example, the CSV file. CSV file will have name, ID, address. It is properly structured data. So the processing of structured data is a supervised learning. Okay. And the predictor is going to be, again, it's a labeled data. So what is the outcome is the labeled data. So the supervised machine learning algorithms are generally take the structured data and then process it and gives them a labeled data, predicted data. Okay, that's supervised machine learning algorithms. What are the for example, linear regression, logistic regression, decision classification, random forest, or KNN, or SVM. All these are generally supervised machine learning algorithms. Okay. The supervised machine learning there are two different types of problems we generally used for. One is classification or regression problems. These are the two different problems we generally deal with. What is a classification? Classification is, we need to classify the data either for one group or other group. So we need to classify that. For example, a given problem which political party is going to win in these elections. This political party is going to win, yes or no. This is the two different classifications: yes or no, or true or false, or win or lose. These are the classifications problems. So the outcome will be either yes or no, or 0 or 1, or true or false, or win or lose. So these are the classification problems. So in that case, it's a classification. And then the other is the regression. The regression problem is it is going to give a real value, or the numerical value we need to provide it. So for example, the particular political party is going to win with this many number of votes, n number of votes, with a majority. So that is, we need to give a number of votes, is the criteria. So that's a regression problem. Or what is this particular political party is going to win with this much percentage of votes. That is again regression problem. So we are going to give a real values. So in that case, the regression, it's a regression problem. So now the supervised machine learning we discussed. Now second category is unsupervised machine learning. Unsupervised machine learning is we are not going to give either a classify or regression, but we are going to analyze it. Sometimes we need not to label the data. We need to give an analysis, and then so for example, we need to cluster the data. So for example, PCA or K-means cluster. These are the two unsupervised machine learning examples we can say. That means for analysis of a customer behavioral data, if we are going to analyze it, so we need to take either PCA or PCA machine learning model, or K-means cluster. We need to cluster it, whether the customer is a low income group or high income group. So we need to cluster it. So basically grouping of data and behavior analysis. In there we generally use unsupervised machine learning algorithms. Now semi-supervised machine learnings are the algorithms which use both the supervised and unsupervised machine learning. That is generally we can say. For example, sometimes we need to label the data, and then sometimes we need to analyze the data. So for example, if you go for a CT scan or MRI scan, we need to label it and analyze further. So that kind of applications we generally use for semi-supervised machine learning algorithms. And finally, the reinforcement machine learning. The reinforced machine learning is the machine learning algorithms where we can use the previous the learning mistakes. And the algorithm for analyze it, and then learn it, and then learn from the past mistakes. So it keep on learns from the past mistakes and corrects it, and then gives the better results. So that's there we use reinforcement and reinforced machine learning models. For example, RNNs is the best example. RNN machine learning, that is, it takes the input layer and then process it and gives the information to the next layer. So it keeps on. So RNNs learns, and then from one layer to other layer. So RNN is one of the best example for reinforced machine learning model. So that's all from today. Thanks for watching this video. If you like it, please like it and share it. Thank you very much. Bye.